My name's Kevin Kane from SCAG. I'm a regional planner here. I handle the demographic forecasting, other research and analysis tasks. My PhD was in geography from Arizona State some time ago. So it's a fascinating understanding the land use and transportation systems of the massive 6-county, 197 jurisdiction, 19.1 million person Southern California region that we do work on here out of this office. We've kind of engaged in, we've been engaging with Data and Donuts and some other venues and things like that under what we call our Future Communities framework, just trying to get a little bit more smart cities and data oriented. And I imagine all of you in your organizations and everything are kind of on somewhat of a similar trajectory. So it's great to be able to have this here. So first step, install our studio. If that's going, you can kind of follow along or raise your hand and Jan will try to come around and help out as needed. So I put up the URL for the GitHub repository, which is where all the course materials are stored. It's github.com/kkane5/our_intro_half-day. And it should be visible there on the monitors that you have in front of your workstations. So I think there are some sessions later on that detail GitHub a little bit more, but this is just a convenient way to deploy everything. And you'll see here, these are the actual files that I have associated with this tutorial here. Everything, all the course materials, actually what we're going through in this workshop is all in this .r file at the very bottom. So in order to download all of these, I recommend finding a place somewhere on your computer, somewhere in a file directory that you'll remember. That's easy. If you're on a Windows machine, you know how everything pretty much gets put in the downloads. I would recommend going back to GitHub and download a zip of everything because we've got a dozen or so files. So if you're on the GitHub repository, again, it's under my profile kkane5 and our_intro_half-day. You'll see all the files here. Clone or download, and then download the zip. You can save it. Usually, again, if you're on a Windows machine, it's probably going to put it down in here in the downloads file or downloads folder. And you can copy it to some sort of a convenient file path that you have on your computer. So what I would suggest doing is taking this subfolder here and just do a copy paste somewhere. I'm going to copy it and paste it into my downloads folder here. So I have a subfolder of downloads with all of my course materials directly in it, just like this. So you'll see here, R is a finicky beast in a lot of ways. If you're for the 2.5 folks who are experienced in R, it's pretty tricky with syntax at times. RStudio makes it a little bit easier by color coding your code and some things like that. But even still, you do have to be very precise with it, which is it's kind of a good lesson in some sense. And I have to admit, I'm entirely self-taught. I started this in about 2011 during a PhD and a postdoc. So I basically had a lot of time on my hands to learn this and to find out how to make my workflow effective. This might not be the most effective workflow for your domain areas, for the types of data you work for and everything like that. But it's extremely flexible software, and hopefully you'll still get a lot out of this, even if it's not exactly perfect. There are just so many ways of doing absolutely everything in here. Again, I'm kind of self-taught for urban planning and geography and socioeconomic types of analysis, but data's data, so we'll do what we can. So I usually use CSV files. That's kind of my main go-to. It just seems to be slicker and easier. You can do an Excel into and out of R. I just wouldn't necessarily recommend it. There are just additional steps to go through. I would recommend saving your Excel, saving your data as CSVs. So you'll see I've got a few of them here. You can just open it up in Excel to take a quick look if you're interested. So that's a GDP growth data set from the OECD, Organization of Economic Cooperation and Development. And I've got some other various files here. So Once you have all of these files in a convenient directory here, go ahead and open up RStudio, which you should have hopefully downloaded, or not, the R-based distribution. So R is a totally free open source software. RStudio is a commercial package that has a very good free version that kind of wraps our code in a much more convenient graphical user interface, or GUI, as it's called if you've heard that term, or if you're familiar with coding in other environments. I asked who has R experience. How about other coding languages and environments, non-R? I see some like kind of half. So there's more halves, so there's more fractionals in here. Okay, great. Thanks. That gives me a good sense that it's mostly novice-ish, which is what this is designed for. So if you've got RStudio open like this, you'll see that there's a console here with a blinking cursor and this little triangle arrow, which is called a chevron. This is where you're going to enter any code to actually execute it. The RStudio environment has some convenient other windows here that are nicely integrated. There's nothing in this one to the right now, or here, because we haven't really started yet. So once we're here, I'm going to ask you to go and open that one file that I mentioned earlier that has an extension of .r at the end. So I just open the file, navigate to where you saved it. Again, I've saved it here. Under Downloads, R Intro Half Day Master. You can see this. And just open this one, School of Data R Intro. You'll notice that there's another .r file in there. And I've just given you my reference card that I've made over the last like 8 years or so of tips and tricks. So that's yours. Sorry if it's a little bit messy at times, but if you're curious about how to do something and it's somewhat similar in structure to what we've learned today, I would suggest doing just a Control F or a Command F in here, and there very well might be something useful or not. You use this. You use the hashtag # to comment something out. This is the code. This is actually your code here. So what I've done is to actually have all the instructions here within the code file. So if you have the # in front of it, it's called commenting something out. So it won't run as a line of code. So you'll see all of these notes here are commented out. And if you actually go to maybe like line 20 here, this is the first actual piece of code. So I put a few resources up here. rproject.org is the actual R website for the open source collaborative project that R is. So this is the base distribution of R and information about that. RStudio, like you've already been to, is the website for the commercial software that uses our code that we're using because it's easier. And I've just put a couple of good cheat sheets here. This statmethods.net is a particularly good one if you're doing any sort of like statistical kind of modeling. And it has a lot of kind of data input management, statistics, little tricks and tips, how to create a new variable, for example. So that's just some resources for you. All right, so module 1 here, I'm just going to go over basic skills in R. And basically, we're just going to keep going through this and get as far as we can through the day. Like I said, it's about 3 weeks worth of material in a graduate course. So we'll get to as far as we can. We've got some cool mapping examples. You can actually do quite a bit of GIS and mapping in R. We're not even linking to QGIS or the other open source GIS packages. And there's just a world of opportunities with R packages, which we'll get to a couple of toward the end. But first, you need to know how to input and output data and do some very basic manipulations on that, and that'll be just so useful. So, ways to run code in RStudio. Line 20 is the first line of code I've got here. First thing you can do, you can simply type something into the console on the left, into this chevron. So I've got the command print, and I'm printing a string of text. The string is hello world, which is just some, I don't know, it's kind of something you do. So that's one line. You can laboriously type your code character by character into here. Another way to do it in RStudio is to just have is to highlight a specific line or a specific section in the code file, which I have over here to the right, and hit this run button up here at the top. So again, highlight and hit run. That's the second way. The third way to run a line of code is what I probably do by far the most, is just if your cursor's on that line, just do Control R or Command R, and it'll run that line of code. So you can see my cursor's here on line 20, anywhere on line 20, and I hit Control R on my Windows powered machine, and it's gonna run that line of code. All right, so we've gotten to running a basic line of code. Like I said, CSV files are really straightforward. That's kind of my recommendation, at least when you're getting started, is to use the comma-separated variable file format. And help is just one line of code away. So you can actually just ask for help from the console here. Lines 25 and 26 here are just ways to get help on the read CSV command, which is read.csv. So if I run that line of code, again, either by typing it in, or hitting Control R, or using this run button at the top right, I'll get here in RStudio the help, all the information on the read CSV command. Usually a command, there's a command and then you have a parentheses and then you have various arguments. Commands take various arguments here. So if I would have a read.csv, I'd have a file name, and then if I need them, there are other parameters that you can enter there. All right, so we're gonna first read in some data. There's a really easy way to do it that doesn't require anything with your file path or directory, and it's here on line 28. What I've done here is take the command read CSV, and I'm gonna use this line here, file.choose after it, not line, sorry, this little segment, and then I'm gonna save what happens there into an object called data. So if I run line 29, I'm gonna hit run up here at the top, highlight it and hit run, or you can use your Control R. What's gonna happen is it's going to open up another little window, and this is what that command's telling you. Navigate to, let's see which one, I want GDP growth. So I'm gonna navigate to where I saved my sample information under our intro half-day master, and go to GDP growth. Does anyone want to tell us where the data went when you did that? Yeah. So if you see a new fresh line with a blinking cursor, that means the command was accepted. That means it worked. That means this data equals read.csv file choose was successful. Now, if you want to actually look at your data, you can just type data. That's line 37, skipping ahead a little bit. That will display absolutely everything in your data set. How many of you work with data that's over, say, 1 million observations or 1 million records? Okay, that I would not recommend typing in the name of your data into the R console here. Okay, so that's the first way. That's the very easy way to read in your data, is to use this little file choose dealie. And data here is not a command. It doesn't show you that right here, but I could call it D. I often just call data D. The next thing I sometimes call D1, D2, whatever. You can name your data whatever you'd like, as long as it starts with a letter and as long as it doesn't have spaces in it, and as long as it meets several other criteria, which the system might remind you of. So the slightly harder way, but the more robust way, is to set your file path. Line 32 here says get WD, get working directory. And if you run line 32 here, this will tell you what working directory you're in. Right now, if I call something from my computer, it's going to be calling it from C, users, Kevin, documents. What I'd want to do in the next line of code is to set my working directory to wherever I put my course materials here. And I have my Explorer here, which can remind me of where that is. It's users, Kevin, downloads, our intro half-day master. So in line 33, I'm going to change this to that exact file path using forward slashes and wrapping my file path in quotes like you have here. So just modify what you have to match your file path. You're probably on a Windows machine something similar to this. Downloads, and then that's our intro underscore half-day master. That doesn't work. The other alternative is to go, and this is in RStudio only, session, set working directory, choose directory, and that'll do line 33. So take a little bit of time with that. You can execute line 34 if you want, and the next few lines, skip ahead. I'm going to help folks who are a little bit behind. Give me a couple minutes and enjoy. All right, how's everyone doing? Cool. So we've got data in, right? For the most part, a couple folks figuring out some last issues, but the bottom line is, all right, we're making progress here. So we've got this object here in R, and it's called data. We've read it into memory. Let's take a look at it in some better ways than just typing data and looking at all of it. Line 40 here is pretty useful. Column names. So there's a command called column names, stands for column names. And if I put in parentheses behind it the name of my data, which in this case is just data, I can run this, and I'm going to get the column names of my data. So looks like I've got 8 columns, an ID number, the GDP of this particular region in 1996, GDP growth, population density, area, unemployment, college education rates, and carbon emissions in the year 2005. These data are all from the OECD stat extract. I think I put the reference in here. It's a useful little sample data set of world regions and some basic indicators. So those are the column names. Oftentimes I want to know how long the data are that I'm working with. So nrow is the command for that. Looks like I've got 331 rows. Head is really easy, is really nice too. Head, which is here on line 42. If I execute that, it's going to give me just the first 5 or 6 lines of my data. So that'll kind of, it's a little bit better than column names because it'll give you, it's not going to display the entire thing. It's pretty quick because it's just reading the first few lines, and it's going to tell you, oh, is this a string of text? Is this a number? Is this an integer value? Whatever. Summary looks similar to head. That's here on line 43. And that's going to give you the summary statistics for each column. Minimum first quartile, median, mean, third quartile, and the maximum value for each of these. I would be careful with this when you're working with data sets of, I'd say, over 1 million rows, because this is actually calculating all of these summary statistics for every single column. So if you've got 1 million rows and 100 columns, you're calculating a lot of summary statistics just by executing the summary command here. A command that's unique to RStudio is here on line 44, and it's probably nice and intuitive if you're not as experienced with the command line interface. View with a capital V for some reason. And that'll actually open up a new window next to your code here of the data itself. And the nice thing about this is it's sortable. So if you click on the data, you can sort it. You can see the let's see, the highest GDP growth is region TRA2. I'm not sure where that is. The lowest GDP growth is JPA. I'm not sure what that is either. My apologies. The nature of sample data in some sense. All right, is anybody having issues with these various ways of looking at your data? Is anyone not able to see their data in this way? One over there? Okay. Cool. Move forward. Sounds good. All right. So that's getting your data in here. If we want to actually isolate one column here of your data and just work with that in more of like a vector format, as opposed to a matrix of data, which we're basically working with here, or generally we'll call this a data frame. But if we want to work with just a single vector, what we can do here is what you see in line 47, which I've highlighted here. You can take the name of your data, stick a $sign, and then put the column name, again, typed exactly, no spaces or anything, and that will isolate just the area 96 column of your data. So I can just type in here, I'm just showing you here, data $, area 96, and you see RStudio has this nice little auto-complete feature. Okay, instead of giving me the whole matrix of data, this is giving me just a single vector of area 96 values. It looks like we've got 331 here. So this is just a list of 331 numbers that I've typed in here. Another useful little hint is if you're in the if you're by this chevron over here, you can just hit the up arrow to go to your previous lines of code. Neat little trick. So data $area96 is a way to isolate that. Now, if we're going to be using that a lot, if we're going to be using this vector of area values a lot, we can reassign that into an object of its own. And I'm going to do that here in line 47, and I'm going to call that object area. So if I run line 47 as is, and then I type area, I'm going to get just that one vector. And here are a bunch of kind of descriptive statistics that you can use to look at area. Length of area tells you that it's a vector of 331 values. The mean of area is 0.031 units. I apologize, I didn't do a very good job of writing the units in the variable name. The median, standard deviation, minimum area, maximum area, and again, our good old friend summary here, which will give you pretty much all of those. How many folks use any sort of linear modeling, linear regressions in their work? What do you guys tend to use software-wise? Excel, right on. Yeah, Stata, okay, cool. Oh, well, okay, you already, all right, sorry, you're like super slowly repeating everything you already know, I apologize. Here's a way to do a basic little linear regression model using this data. What factors impact, in this instance, GDP growth, gross domestic product growth? I can run line 57 and then line 58. Sometimes it's a little bit helpful to drag your windows here to give yourself a little bit more space for some of your output. So I'm going to do that again. I'm going to run line 57 and 58. And we'll get back to this later, but I just kind of wanted to indicate this is some of the things you can do with a data frame or a matrix. What I've done here is to use the command called lm, which is linear model. And I'm going to put a y variable or a dependent variable here, GDP growth, use a tilde to separate it, and then do a bunch of independent variables here. So my hypothesis in this instance would be that gross domestic product in 1996, population density, unemployment, college education rates, and carbon emissions cause GDP growth. So I'm going to run this command lm and save the results in an object that I call model. I can call it M1, I can call it output, I can call it pretty much whatever I want. And then I'm going to do a summary of the model, which is here in line 58. And this is where you can see, if you're familiar with linear modeling or linear regression, that's where you're going to get all your regular coefficient estimates. You can see this isn't a terrible model. It's got an R-squared value of 0.31. And it seems like there's an inverse relationship between GDP and GDP growth. So the less wealthy regions are catching up. Population density is positively correlated with GDP growth. And oh, look at that, carbon emissions are positively correlated with GDP growth. We do a lot of long-range greenhouse gas emissions planning here at SCAG. So that's just kind of a little bit of a taste of linear regressions. There are so many different packages for different types of estimators, different types of diagnostic statistics, things like that. And we'll get to packages a little bit later. If we plan to use GDP 96 a lot, which I'm going to in the next few lines here, we can make it a little bit easier by just isolating that vector and then renaming it GDP. So that's line 61 here. Again, I can take a look at GDP, see how long it is, take a look at the summary. And one of the really nice things about R is the graphical output. I always love doing graphics in R that could easily be done in Excel, because it's like you get that Excel look, with your graphs. R will get rid of that Excel look. That's one advantage for sure. So line 64 is just the easiest little command, hist, for a histogram. I'm just going to do a histogram of GDP. Control R, Command R, and then I'm going to get a very basic histogram of GDP across my 331 world regions that we're looking at. You can see it's pretty right skewed. Kind of curious as to which region this is over here. And then, like I mentioned, the commands in R take arguments in parentheses, separated by commas for the most part. So what I can do is I can make this histogram a lot fancier by adding various parameters. So in line 65, I've done just that. I've told it how many breakpoints I want to have. I've given it a series of X limits from low to high. From the low, I want to go from the minimum of GDP, and the top, I've said I want the right parameter to be 60,000 because I don't need to be displaying this high outlier here. I'm going to put a label on the x-axis, a label on the y-axis. I'm going to give it a color. I'm going to give the border a color, and I'm going to give it a main title here. Again, if you want kind of a reference or a way to see what all these possible arguments are, you can just type help hist for help on the histogram command. And then you'll get a list of all the various arguments: frequency, density, angles, axes, plots, a description here in the details, more descriptions, references, and some examples. Sometimes these aren't necessarily the best or most accessible descriptions. If this doesn't really provide what you need, the Google does a great job as well, or something I just heard about called DuckDuckGo, which is, I guess, an open source version of a search engine. Joe over there taught me about DuckDuckGo. If you're kind of an ant, yeah. Sorry, yeah, huh? Oh, really? Oh dear. Anyways, I guess I feel bad for using RStudio even though. In any case, or check out some of the resources up here at the top. Statmethods.net is a particularly good one. So if I run this fancier line of code, line 65 here, again, either just running, copying and pasting into the console, or putting my cursor there and hitting Control-R, I can get a much nicer, definitely report-worthy, definitely publication-worthy looking thing. Now, there's a few ways to save this graphical output. In your basic R distribution, it's a little bit trickier because you typically have to specify the file type and the number of pixels and the size and whatever. I have an example here of how to save it as a PDF, which is just a little bit easier. So I'll show you how to do that. But also in RStudio, you can export fairly easily as well. So easy way first or hard way first? Hard, okay. The hard way first involves 3 lines of code here, 68 through 70. You're basically going to use a PDF command, specify a file name, run your histogram or whatever it is, and then tell it to stop in line 70, dev off. So I can select all 3 lines here like this and run them, either by hitting run or by hitting Command R. And I don't know what happened. Okay, so clearly, if you have this clean chevron here, if you're able to type a new line of code, that means it's been accepted. That means it worked. So where did figure 1 go? Well, whatever your working directory is. If I go back into my file explorer here, I can see that there's a new file here, figure 1. Which is a PDF version of regional output. So that's kind of the more code-based way to output your graphics. Alternatively, if you're working in RStudio like we are here, this graphics window here has a fancy little export thing. You can save the image, change the parameters a little bit, a few format options, change the directory, or you can copy it to the clipboard and then paste it into whatever else you're working with. All right, so this is the data basics, section 1A. I think we have a break scheduled at 10:30, so I think we're going to get through the next section, but I wanted to go around the room and just kind of help folks if they have any questions or anything like that for 2 minutes or so. Sound good? All right. All right, so I kind of like doing those because I learn stuff too. Every person's configuration environment is a little bit different. I've been working on this exact computer since I first learned R in 2011, so that's one of the reasons I had to have the AV team give me a weird port for it. A couple of things, as you noted before, sometimes it's not Control-R, it might be Control-Enter. So if you're not able to run a line of code just using keystrokes, try Control-Enter. Second thing, for display purposes, you're clearly going to be using this code file a lot. You're working in here a lot, and you generally want to see the console. I like having them on two sides like this. If you want to configure the graphics a little bit better, you can go to View, Panes, Pane Layout. And then you can pick what you want in each of your 4 quadrants here. So I like to have the console on the top left, the source code, which is the code we're working with, on the top right, and then all your other stuff, you can leave as is because you can easily minimize or maximize that. Any other questions or anything? You can press the little speaker button on your microphone. Or suggestions, things you figured out, tips, tricks, etc. Yes. Some R people definitely don't do it that way. Oftentimes they'll do what I have here on line 76. They'll do the less than sign and a hyphen. In my application, areas equals has been sufficient. I can't remember. I'm sure you guys know the difference between the equals and then this here. Some R people don't like using equals. For some reason, I started using equals and it's never been an issue. I guess I'm not that cool, so apologize. Good point, though. Anything else come up? Any other questions, comments? Yeah, I've also been informed the break is at 10:45, so bear with me for another 39 minutes, please. Is that Lyle? It's 10:45. Lyle will double check.
Yes, it is.
Thank you. Yeah. Appreciate it. All right, so we've gone through Module 1A, data basics. Let's do a little bit more data manipulation, and then we're going to get into a little bit more of a hands-on lab using what we've learned here for kind of combining a bunch of data sets together, census and other data, and then I'm going to do some of the packages and some of the spatial data applications. It's going to go faster, don't worry. Or worry, I mean, depending, yeah. Okay, so data manipulation. We've got the data read in. We've been able to look at it effectively. We even did a little linear regression and a little histogram. I'm here on line 76. One command that I find very useful is a subset command. There are a couple of ways to do this, but I like the subset command in particular. For some reason, I just find it intuitive. What I do here with the subset command is I can take a subset of my data frame, which is called data, and then give it an equal sign, a greater than, a less than, what have you, or a not equal. And then it's going to give me a subset of my 331 rows in the data frame here, based on whatever I give it. So if I'm interested in making a histogram or doing some analysis on just the higher GDP regions of the world using 1996 data, I can take a subset of data such that GDP 96 is greater than or equal to 25,000. I'm going to take that subset and then I'm going to assign it to a new object, a new data frame called high underscore GDP. So if I run line 76, then I can look at high GDP here on line 79, and row of high GDP, I see I have 121 rows. The column names of high GDP, you can see, are exactly the same. Do a head, or you can do view with a capital V, and it'll bring it up here. And you'll see that there are 121 entries if you look at the very bottom of this view window here, again, which can be sorted. If I sort this GDP 96 here in ascending fashion, you'll see that the lowest GDP in this data frame is 25,011, which means it worked. Anyone have any idea of what the not equals sign is? So I've got a greater than or equal to. I can change this to a greater than. I can change this to a less than or equal to. Ah, good guess, good guess. Does that work? There might be various ways to do it. I use the exclamation point equals. Yeah, double equal, yeah. So if I want, if I'm anticipating there to be multiple regions with a GDP of 25,000, I can change it to a double equals. Well, I have no regions with a GDP of exactly 25,000. I could also do a not equals, which is an exclamation point equals sign like this, if I want to just do a subset but omit one of the options. But what I had here is high, so I'm going to do greater than or equal to. All right, so we've been able to slice by rows, given an argument. What if you're only interested in just keeping some of the variables? You've got a ton of variables in this, actually not a ton, you have like 7. But what if I wanted to make a data frame of just a few variables? So let's take a look at the columns names that I have working with here. What I can do is I can do a little bit of a slice here. And it takes a couple of steps, lines 83 and line 84. Line 83, I'm going to list out the columns that I want to keep. So here I'm keeping GDP 96, pop dense 96, and area 96. I'm putting each one of them individually in quotes, separating them with commas, encapsulating them in parentheses, and putting this funky little letter C here. C stands for combine. Basically what I'm doing here is I'm making a list of 3 strings, and the strings are going to be the exact same as the column names here. I'm going to call that my vars, my variables. So if I run line 83 here, I get my vars or my variables, and you can see it's just a list of 3 strings. Length 3. Now I can do a little bit of operation here. I can take high GDP, put my vars in brackets behind it. Brackets will often do some sort of slicing of some kind of varies, but it's some sort of a slicing operation is how I like to think of it. I'm going to slice high GDP by my vars, and I'm going to output that. I'm going to assign that to a new data frame called high GDP2. And that's line 84 here. And let's take a look at head of high GDP2. Or summary high GDP2. Uh-oh, I messed up. If you mess up like this, go back a few lines, I would suggest. Make a new high GDP. See if it's all right. Okay, it's got 121 rows. I messed up because I was doing a greater than or equal than sign up here. Take a look at my variables. Make this string in line 83, and then slice high GDP by what you've made in line 83. So run line 84, and then line 85, you can do a summary of what you've just created here. So you can see that there are only 3 columns here. Is that working for folks? All right. So that's how to slice by rows and how to get rid of some columns or manipulate the columns if you want. All right, slicing and dicing single vectors. Next topic here. So if I want to, we've already gone over this. If I want to just isolate the column GDP 96 and assign it to a new item, I'm going to call it GDP. Run this line 88 here. It's always good once you create a new object to take a quick look at it. Summary, number of rows. Oh, that doesn't make any sense. I can't do number of rows. It's a vector. Length, 331. All right, so I know what I'm working with. Another way to just extract the second column from GDP is by using brackets, slicing like this. You can extract a column, you can extract a row, you can extract a single observation here, and it goes row, comma, column. So what I'm doing here in line 89 as it's constructed, I'm not specifying any rows. So there's nothing before the comma here, which means it's going to be all the rows and only column number 2. So this is going to, line 89 is going to give me the exact same thing as line 88.
Columns start at 0 or 1?
Columns start at 1. This is not Python. Good question. Any other questions? Please feel free. Use the little button on your microphone here. A colon can be used to select a range. So I've got this GDP here, which is just a list of numbers. And if I want the 1st through 10th observations in line 90, I can run that. If I want the 1st through 100th, I can just do GDP 1 to 100. I can even assign that a new name in line 91, GDP 10. So I'm working with just the first 10 observations. It's a short little list if I want to do some manipulations or a histogram or something like that. Sometimes what happens really commonly is you want to flag certain observations. If there's a 0 value or a missing value or a null value, the R system classification for missing or not there is the letters, capital letters NA, like this in line 92. So if I figure that one's below 2000, for some reason I can't trust that data, or I want to exclude it, I want to exclude that value, I can reassign them as NA. So what I'm doing here in line 92 is I'm taking the observations in GDP 10, which are below a value of 2000, and assigning them a value of NA. So I've got GDP 10 here in my console window. I'm going to run line 92, and then take a look at GDP 10 again. And I can see here that the first and the third observations, which were under 2000, are now NA. Super useful. Next thing, if you want to exclude those, if you want to exclude NA values, ones that you've just created or things that came with an NA value, that's line 93. So what you're doing here is you're taking GDP 10 and you're basically slicing it by the opposite of the NAs, is kind of what's going on here. So I'm looking at, so inside of the brackets, I've got exclamation point is.NA parentheses GDP 10. What I'm doing here is I'm taking GDP 10. I'm looking for the instances where it is NA. I'm looking for the opposite of that. And then I'm slicing GDP 10 by that whole thing. And I'm going to call it something new. I'm going to call it GDP 10 2. So that's line 93. So GDP 10 2, if I look at how long it is by doing the length, I can see that it's now 8 observations. I've excluded from that vector the 2 observations that are in NA. If I want to just sort my vector, you can just do sort. But keep in mind that that's just going to be a one-time deal. It's not going to save it as a sorted vector. See, it's not quite in order. The first few are, but it's not in the same exact order. You can also sort in decreasing order by adding another argument to the sort command, decreasing equals true. If you want a little bit more info on the sort, help, sort, partial, NAs, decreasing, some other methods, other stuff you can do with sorting. This is super boring, but I promise you, if you're working with this in the future, you'll go back to this and find it useful. Like, how the heck do I do an NA flag? All right, any questions, any thoughts, any comments? Anyone need some help? Yeah. The question is, how do you save a sorted file or a vector? You can simply, I'm pretty sure, just assign it. So I'm gonna do a little bit of modification to line 95 here, which is the sorted version. Call it GDP sort. And do my sort command, and in front of it, I can tell it to save that in a new object called GDP sort. Thank you, good point. Any other questions, comments, etc.? What's up? How can you get the, okay, just hit enter a couple times or escape a couple times. Does that work? Clear it out. I'll come over, I've got a few more items here, and then I'll do another quick round. All right, so we've sliced and diced a little bit on vectors. Let's go back to matrices or data frames, the whole data set here. If I want to sort the entire thing by the values in a specific column, we've already done that once, the view command. So view with a capital V, data, and you're going to get a nice little view here where you can sort by any column dynamically. If you want to do that in your code for some reason, if you're merging data or what have you, you can do this what's here in line 99. You can basically do this same, use the brackets to kind of slice and give it a command here. So what we're doing here is we're ordering the data by carbon emissions, by the carbon emissions column, leaving the after the parentheses blank, and then assigning it to a new object, and I'm going to call that data2. So if I run line 99 here, and I do head data2 to look at the first few observations, I'll notice that data2 is a new data frame, which is a sorted version of data, and it's been sorted by the carbon emissions column, CO2 to 2005, in ascending order, starting with the lowest carbon emissions to the highest. I think that's Estonia, so congratulations, Estonia. Scroll down to LA. Yeah. All right, so if I want to remove some things, you can sometimes use the negative sign for that. If I just want to remove the last row, this is a convenient thing. Sometimes if you read in data, there's some junk on the last row. You can do a negative nrow data. So nrow data, the output of this command is just a number. It's the number 331. So basically what I'm telling this to do is to make a new data frame called data3, where I get rid of, using the minus sign, row 331. You can see that instead of typing 331, if I don't want to have to count each time, I can just specify the command that outputs 331 in this instance. So data3, I can now see is 330 rows, not 331. Good. If I want to keep only the first 4 columns, here's another way to do it. Combine 1 through 4. Summary of data 4, I can just get the first 4 columns in there. And importantly, if I want to just remove one variable, perhaps you messed up or something like that, you can just make it equal to null. So I've got my summary of data 4. It's got 4 columns. If I want to get rid of popdens 96, I can do data for $popdens 96 equals null. Do a summary of my data again, and then I can see that it's gone. Here's a useful little trick here. Sometimes you need an index number. If I look at my original data, head data, this is basically R's listing here. This is not actually a variable. There's 1, 2, 3, 4, 5, 6 at the side. If I want to actually give a sequence, for example, if I've sorted data and I want a new rank column, what I can do here is make a new vector using this sequence command. I'm going to do a sequence that starts at 1 and that goes to the length of data GDP 96. So I can check out what that is. 331 again. Sequence of 1, 2. Basically just 1 to 331. And I can call this index. Now what I can do here is what's called a cbind command, or column bind. There's also a row bind, which is rbind. Pretty useful here. What I'm going to do is I'm going to cbind, I'm going to column bind this vector, and then which I've called index, and then my data frame D, and I'm going to call it data 5. So I run line 110 here, take a look at the head, first few rows of data 5, and I can see that there's a new actual variable here that's called index, which is basically the rank by whatever I've sorted it by. Last step here is going to be actually saving your data, writing to CSV. So if I've got data 5 and I've done some manipulations, I've added some variables, I've bound some stuff together, this is the write CSV command. Previously we had the read CSV command. Notice we're not assigning anything here. We're basically taking our data frame, putting a comma, and then in quotes we're giving it the new file name. Make sure there's the .csv, make sure it's in quotes, and then run it, and then who knows where this goes. Your working directory, whatever that is. Kevin downloads our intro half-day master. If I go there, I can see, what is it called? GDP subset. Call it GDP subset. And then I can open that up, look at it in Excel, see what I've done there. All right, got about 20 minutes or so. I would suggest either we take a break now or we start to get into the next module, which is a little bit of a deeper dive. All right, working with multiple data sources. I think one of my favorite things about R is the flexibility it gives you in combining stuff, and it does so in a replicable manner. You can run the code, you can go back to see exactly what you did. No more messing with version 5, version 6, version 18. or whatever. So a few useful tips and tricks. Who here is familiar with the concept of a preamble? Not like we hold these truths to be self-evident that all men are, no? Okay. A preamble in that before at the very top of a code file, you'll often just put some basic information and you'll put some lines to kind of set up your coding environment. That's often useful when you're using packages in R. Setting your working directory is something that you'll often do in a preamble up top. And if there are some types of parameters that you like to use, for example, that one example of setting your delimiter type, if you need to do that, I'm sure that's something you can do in a preamble as well. So here are a couple of useful tips and tricks. Some of them might be relevant for a preamble. One is ls. Well, this isn't really preamble material, but ls here basically lists all the current objects. We've been playing around a lot and assigning a lot of things. So right now I've got 13 different objects here: data, data5, GDP10, myvars, whatever. If I want to remove one of them, I can just do rm, for example, area, if I want to get rid of area. If I want to remove all of them, I can make a list of ls and then wrap that inside of the remove command. And then I'm going to remove all of my objects from memory. So, I'm a little hesitant because I can't remember whether or not I referenced some of these things later in the tutorial. So I'm actually going to skip line 124. I apologize if you've already run it. You're probably fine. If worst comes to worst, you can just literally like run lines 1 through 113 all in one fell swoop by highlighting all of them and get back to where we started, unless there are some errors, which there might be. Here are two things that I enjoy putting in my preamble. Options, SciPen 999. You've noticed in the linear regression example and some other instances, the histograms, for example, it defaults to scientific notation after, I think, 1 million usually. This is one way to avoid printing in scientific notation. Just run this, and that'll be saved. So that's something you want to put up. Strings as factors equals false. Depending on, I work with a bunch of different disparate small to medium-ish data sources in general, and some of them have been manipulated and worked on by other people, and you don't know exactly what you're getting. Sometimes things get read in as factors instead of just numbers. I don't know all the ins and outs of it, but I've found this extremely useful for just general troubleshooting. Strings as factors equals false. So I put that in there for your consideration there. Next step here is we're going to merge some different data sets from different sources and analyze them. And the research question that this little mini lab is going to be doing is, what predicts domestic migration in California's counties? Housing cost or job growth? So what causes people to move from one county to another? Is it the push factor of housing costs being too expensive, or is it the pull factor of job growth causing people to migrate into a county within the state? So that's what we're going to be using data to answer. And again, to really answer this question, you might want more than just 58 data points in California counties, but this is an exercise and it kind of does have a meaningful bent to it. So thank you for that. All right, so I have put a CSV file called CADOF popchange E6 into your directory here. And this is from the California Department of Finance, who basically does the population estimates and forecasts for counties and cities in the state. So I'm going to read that CSV in and call it DOF. I'm going to take a look at this DOF file with a view and see what I've got here. And I did a little bit of manipulation on this just to make it a little bit friendlier. But they do provide you with the components of population growth: the births, the deaths, the births minus deaths, which is the natural increase, level of immigration, level of domestic migration. And what I've done is I've put these values here for 2010 and for 2017, so we can do a little bit of a longitudinal model as well. I've also added a column here for which Metropolitan Planning Organization, or MPO, to see if these are SCAG counties, ABAG counties for the Bay Area, SACOG, Sacramento area, SANDAG, or non-MPO. ones from the smaller areas that have smaller councils of governments or nothing. So that's what I have here in the DOF, if I read that in. Next part is going to be a little bit of a trickier exercise. I did not provide the data. I'm going to make you get the data. Thankfully, the government shutdown ended, so the Census Bureau's website is being updated regularly. I remember during the 2013 shutdown, I was pretty much out of work for 2 weeks because they shut it down entirely, including the server. And if you had any APIs or anything, yeah. Did anyone else come across that problem? Okay, maybe it's a pretty narrow thing. So, all right. So what we're going to do is we're basically going to, I'll just give a quick overview. We're going to go to the Census Fact Finder website, and we're going to download county data from the American Community Survey on median home values. We're going to transpose it, download it, and put it into the working directory that we're using as a single CSV file. So all the instructions are right here in lines 135 to 139. Feel free to go at it at your own pace, and I'll just kind of go slowly up here so you can watch along with me. Sound good? All right. So I'm going to go to factfinder2.census.gov. All right, and this is where you're going to extract most of your census data if you need a little thing like this. Always go to the advanced search because we're advanced users. Show me all. Now I said we want data on California's 58 counties. So these are all the search options you've got. You can type in, you can search, you can pan through topics and data sets, geographies, other components as well. I would recommend starting with geographies because this is the nature of your observations. We're looking for counties. If we're looking for census tracts or something else, certain things, are available for counties, but not for census tracts. And, especially because there's less data and less accurate data available at a small area. So I would go here to geographies and select your geographic type. You can select huge numbers of things, and this is actually only the most requested. If I switch to all geographic types, I'm going to get a ton of various different things. County subdivisions, Alaska Native voting districts, remainders of voting districts, combined New England towns and cities, etc. But all we want to do here is counties. So there's a county right there. It's a 050 is the code for counties. Select a state, which is California. And then select all counties within California here. And then once you've got that, hit add to your selections. So what I've done here is I've told it to basically display all the data that is available for counties in California. I can close this and you can see tons of stuff starting with age, population, etc., with various vintages of data available on the right here. So after I've got that, I want to go to topics and select the data set. So you can actually select the topic here, but I've got a slightly easier way to do that. I want to go down to this data set button here, and I want to select 2017 ACS 5-year estimates. This is the American Community Survey data, which is a sample of the population. It replaced the census long form in 2010. It gets you all the more detailed information about housing costs, behavior, commuting patterns, industry type, everything other than the real basics of population. The 5-year estimates give better standard errors at the small area level, and the data is not as censored. So you can actually get data for small areas when you can't at the 1-year sample. The shortcoming of the 2017 5-year estimate is that it's actually collected over a 5-year period between 2013 and 2017. So you're sacrificing spatial resolution for temporal resolution. That being said, there are some really small counties in California, like Alpine County, population of roughly 1,000. And actually, housing price data are not available in the 1-year sample for Alpine County, California. So when I wrote this tutorial, the 5-year data had not yet been made available. It will require one little switch in a code, and I'll get to that. In any case, let's select the 2017 ACS 5-year estimates here. And then I want to get table number B25077. So up here you can type B25077, which is the median home value in dollars. And click go. And then you'll see that there's just one option here. I've gotten rid of all the other ones. And I can click on median value, this data set. And here we go, the median home price for each county in California. Alameda, $649. Whew. All right, so usually our observations are counties, so we'll need to transpose this data. There are a few little tools you can do here to do a quick transpose. So if you go up to this button, Modify Table, click that. And then you've got a Transpose button here where you can transpose the rows and columns. And then you've got the estimates, margins of error in a better format. And there are little, if you get lost or whatever, there's instructions in the R code file for all of these little selections you're making here. So I want to download these data, and I want to download them to use them because we're advanced people. Okay. So download that. You'll probably get a zip file to your downloads folder. And that zip file will typically contain 4 things. Some metadata, some information about owner-occupied housing units, what have you. But the one that you want is this here that has with an at the end, with ANN at the end. So it's ACS 2017 5-year data. It's series B 25077 with annotations. I'm just going to open that in Excel to take a look at it. And it looks like I've got 58 lines of data here. These look like counties, and I have an estimate and a margin of error. So this is the CSV file here I want. ACS 17 5-year B 25077 with AN. So I'm going to copy this file and put it into the working directory for this tutorial here, and just do a little copy paste. Keep the name the same. Don't need to edit anything in Excel. All right. So I apologize if that's repetitive for you, but that's how you grab little pieces of census data as you need them. So back in the RStudio console, we've got this this line 140 here. Now you can just read the CSV in like normal if you want, but if you noticed in Excel, and I'll pull it up here again, the census data downloaded from Fact Finder usually have two headers. One is the code, and then one is a description of the code. I find that annoying and frustrating in R, so my workaround has been to read in the data a little bit differently so that I don't have to do any pre-manipulation or pre-processing, so that I can take it straight from what the census gave me and read it into R. So what I've done here is a little bit of modification to the read CSV command. And I've got the file name here. And what I've done is I've stuck a -2 in here in brackets. Basically what this is doing is it's omitting the second line only. So the first line has the code, the variable code. The second line has a description. But when I read it into R, I want it to only believe that there's one header. So I'm just going to omit that line. I mentioned to you before you need a teensy bit of manipulation here to the file path because now ACS 5-year data are available. So in this line, where it says ACS 17 1-year, just change that 1 to a 5. And then read in line, run line 140. And then take a look at your ACS data. All right, ready to press on? Cool. So I think where we left off, if everybody's left their machines open, we have read in this DOF data from the State Department of Finance, population, births, deaths, natural increase, immigration, domestic migration, 2010 and then 2017. And we've gone to the recently reopened Census Bureau's website and downloaded California county data on median household income and stored that in an object called ACS. That's where we left off, I believe, right? Cool. All right. So we've got our population change, which is going to be our dependent variable eventually. We've got housing price to test the hypothesis of to what extent does housing price cause people to leave the area or come to the area. Next thing we need are employment data. For the sake of simplicity, I've just provided it. It's from Bureau of Labor Statistics, BLS. There's the link and the table itself if you'd like to look it up. But this should already be in your working directory here under BLS EMP. So we can just run line 144 and get the BLS data. How many rows? It's got 58. That's good because there are 58 counties in the state. Take a look at the head of this to see the counties. And I've got the last 3 years of employment data patched to here. So the next thing we're going to go into is what I find to be one of the most useful commands in R. There's a few different ways to do this. Again, there's tons of ways to do everything in general. This is what works for me and my workflow the best. So that's why I'm teaching it to you here. Who uses VLOOKUPs in Excel? All right, this is analogous to a VLOOKUP in Excel. The bottom line is you don't need your data to be in any particular order. All you need is for it to have a identifier column in each piece. So we've got 3 data sets here, DOF, ACS, and BLS. They all have some identifier of county codes. And we're going to join them all together. We're going to actually use the DOF file as kind of the basis. We're going to join columns from the other 2 to the DOF file and then use the DOF file for our analysis. And we're going to use the unique identifiers in them. So line 149 is one of the examples of this. And let me unpack that for you a little bit. What this is saying here is that we're going to take the data frame DOF and we're going to add a new column called HOVAL16 to it. HOVAL16 is going to be equal to this particular column in ACS, HDO1, VDO1, which is, if you look at it, it's the value for median income. So DOF HOVAL16, I'm sorry, not median income, median home value, duh. That's what it says, anyways. So ACS home value, I'm gonna append that and I'm gonna call it HOVAL16. And I'm gonna kind of slice it here with brackets, use the match command. And inside of the match command, what I'm doing here is I'm declaring the value of the unique identifier. I'm declaring what the county code is called in both DOF and ACS. If I look at my DOF data, I can just do head DOF again, dog. And I can see here that I just have an ID number. It looks like it's a 4-digit identifier. Actually, if I want to look at what type, that's not R. Sorry, type of. It's an integer. So it's an integer value. One of the tricks with working with census data, sometimes especially in the state of California, is our state code is 6 or 06. So sometimes it will be a string because it starts with a 0 when you're moving it between different things. Our codes for census tracts, for example, are 1 digit fewer than the codes for census tracts in most of the country, just because we have a leading 0. It's extremely, extremely annoying. Almost made me leave the state because of that leading 0. Although there's other nice things about California. In any case, I digress. So what we're doing here in the match command is we're taking this ID value, and then let's look at ACS again here. Let's do head ACS, and see that it's actually called something different. It's not ID, it's geo.id2. And what we can do, and so let's just run this and see what it does. Line 149, take a look at DOF, and voila, we have a new column in the DOF data frame for home value, which is brought in from the other source. I can do the same thing for 2017 employment from the BLS data. I'm going to take EMP June 17 and EMP June 15 from BLS and create a new column for those 2. Make sure to keep your naming straight. The Census Bureau names are not very intuitive, so I've given it a new, more intuitive name here. In the BLS, I'm changing the name slightly as well. Good practice to change the names as few times as possible, just so you don't get confused. Again, R is very finicky. If you mess up one character, it messes up everything. And if you look at the BLS data, your identifier that's going to work here is just called GeoID in all caps. So you can do this one time for each row. Extra credit if you can turn this into a loop. Sometimes you have 50 columns from BLS that you want to join to DOF, for example. So you would have to do a loop structure around this, which I'm not going to get into because we have 3 hours, not 3 months. All right, so I can run 150 and 151. And then if you do a view, you can see the DOF now has all those extra columns in it. That's really the beauty of this, is being able to put in all these data sources together effectively and in a replicable manner. We can do a little bit of math here. If we want a percentage variable here in lines 154 and 155, I can make a new variable of the percentage employment growth and the percentage population growth, just by doing the difference over the original value. So I've got those growth percentages there. And let's see, who is the leader in California population growth? 9% population growth from 2010 to 2017. Placer County, okay. And the least is, Susanville, Lassen County. Negative 12% population growth between 2010 and 2017. In Los Angeles, we are over here with 4% population growth, 4.4, between 2010 and 2017. Not annualized, so. All right, so now we've got our data frame that we're going to work with. So let's compare the size of a county with its median home value. Do bigger counties tend to have higher housing prices or not? Not necessarily the most interesting research question, but it's useful here to display. So good first step when you're working with plots and when you want to interact multiple variables, just look at how your data are distributed. Look at a simple histogram. So line 162, I'm just going to do a histogram of home value in 2016 across California's 58 counties. You can see a little bit of a right skew, a couple of high outliers here where the median home price is over 800,000, but the most are between 200,000 and 300,000. I like to add breaks sometimes in the histogram. You can just play around with the number of breaks if you want a little bit more precision here. You can also do a box plot. This box plot here is going to give you a side-by-side where this is the median here. You've got the, I believe this is the third quartile, first quartile, high and low values, and if there are any extreme outliers. So you can compare side by side the distribution using a box plot. Not quite as intuitive as the histogram. On the left side is population growth share, and the right side is employment growth share. So population growth has a bigger middle chunk. Employment growth is a little bit, looks to be a little bit more right skewed here, I think. Because of the skew that we're clearly seeing, I'm going to pull up this histogram, this first histogram again. We've got right skew here. Using socioeconomic data, often it's helpful to take a log, to do a log transformation, take the logarithm of it, and then you get a more normal distribution, a little bit more centered. You can spread out the counties a little bit more effectively in terms of population, because you've got Alpine County on one end and LA County on the other end. All right. Here in line 168, we can use R to make a nice little scatter plot. The command for that's just plot. And you can plot, an X and a Y. What I've done here is to declare an X and a Y first, and then run plot. Certainly, you can do this a little bit differently by saying plot DOF whole val 16 and then log DOF pop 17. Or if you're going to be using X and Y subsequently, it might be nice to assign the variables like this. So I can run all these 3 lines here. And you'll see it's running up here. I've just made my window a little bit smaller. Here we get a scatter plot of home values on the x-axis and the log of population growth on the log of population, on the right axis. And you can assume somewhat of a positive correlation probably between these two things. You can see this runs the exact same thing, just gives me a little bit different default parameters. What I've got here between lines 174 and 183, this is a bunch of code that I kind of developed. I could have wrapped this in a function, made a separate function, but this is a scatter plot and a best fit line that works pretty well for me. And this might work well for you as well. What this basically does here is it does a scatter plot it adds a best fit line, and then it reports some of the basic diagnostic statistics in the bottom right-hand corner. So that's what this entire big section does. I'll unpack it a little bit for you here. First, I'm going to do a regression, linear regression. What's the impact of X on Y? Those results will be stored in model. Before we looked at linear regressions, and you can do summary of model, and you can get the impact of X on Y. But we're not really interested in necessarily all of the diagnostic statistics for a regression. We're really just using this to get the best fit line. I'm going to do the same plot before. I'm going to plot X and Y. And then I'm going to add some parameters here. You can specify a Y label. You can put a string of text in here, YLAB equals. And then separate it by a comma, add another argument for X label. And then main will give you the header, the big title up here. You'll notice because previously I ran one of my preamble commands, options scipen equals 999. What that's done is it's gotten rid of the scientific notation that was coming up in our plots earlier. A little bit more convenient this way, but it's up to you as to how you want to change it. I did this regression because I'm going to add a line, AB line. I don't actually know what it stands for. AB line, maybe, something like that. It's a command, and it can add a line to an existing plot. I'm going to add a line from model. I'm going to give it a color of blue, and I'm going to give it a line width, LWD, of 2. And there's my best fit line. You can play around. You can also change the color to chartreuse. And this is a good time to show you one of the helpful materials that I put in here, our short ref card. There's just another resource for you that you can do a quick Control F, Command F, and find something. If you want to know which colors are available to you, there are so many, and they all have gold, khaki, lavender blush number 4, etc., etc. Dark orange, dark red, blanched almond, fire brick 4, floral white, Gainsborough. Dodger blue is one that I've used before. So actually, let's just do that one for the sake of civic pride. So there's my Dodger blue line. I'm going to actually refresh the plot because each time it plots it, it goes over it. And then these next lines here, I would recommend not touching or doing a deeper dive if you want to. But what this is doing here is it's putting these regression diagnostics on the bottom right. You have your R squared, which is the measure of the fit of this line. How good is the relationship between median home value and population? You've got the p-value, which tells you if it's a significant relationship. Remember from Stats 101 that if a p is below 0.05, that typically means it's a significant relationship. So this is fairly strong here. And then I've got the coefficient estimate here, which is the actual magnitude of the relationship. Typical diagnostics that'll be useful if you're more advanced, or just make it seem like smart to have on there. So this is your little scatter plot of the relationship between median home value and log of population. Play around, stick a different variable in there. You know, try population 2010 perhaps. And you'll see that it's slightly different. I can't remember what it was before, but. You can do a simple correlation coefficient, core.test. Let me give myself a little bit of space here to get the correlation coefficient, the R value. I put the R squared up there, but you can get the correlation value between home value and population size. It's a 0.473 over there. This will give you all the diagnostic statistics if you just do core.test here. That's the name of the command. I've got X and Y, confidence interval, t-statistic, p-value, etc. So the last thing here is our original research question. What drives domestic migration? So let's do a linear model here again and dive a little bit deeper into how that works. Again, who kind of uses, who's somewhat familiar with regressions or linear modeling or uses that from time to time? Who has heard of, or is at least vaguely familiar with, regressions and linear modeling, or learned that in one class a long, long time ago? All right, that's most of us, great. So this is a fairly easy way to do it if you find this useful in your own work. Basically, I'm putting my independent variables here. My hypothesis is that population in 2010, what's the contribution basically of employment growth versus home values to domestic migration? And I'm actually tossing in a control variable here because most of domestic migration is just the size of the county. There's more domestic migration from LA County because it's huge than Alpine County. So what I can do is stick another independent variable here. It's kind of convenient. One of the arguments you can add to the LM or linear model command is the data set that you're using. I'm using the data set DOF, so I can declare it here, and then I can dispense with the tradition of using a $sign, for example, like this, in order to tell the command which data I'm drawing from. So if I run this, and then if I look at a summary of the model, I can see my usual regression output diagnostics. And I was talking with the gentleman in the back over there. You can simply slide, if you need a little bit more room to see your output, you can just slide your console wider and then rerun the command. You can just do an up arrow to rerun the command, and then you'll be able to see it here. So let's take a look here at what drives domestic migration. Well, like I kind of hypothesized, population has a really strong inverse relationship with domestic migration. I can't recall how I transformed the variables. In any case, it's a really strong one. 3 stars here indicating a really low p-value that I'm using more as a control. But we're looking at the contribution of home price in 2016 and the percent employment growth, which we transformed earlier. So it looks like employment growth has a little bit of a stronger signal here. We've got a p-value of 0.0538, and then home value 0.1039. We can't really say that home value is significant, but the signs are right. Okay, lower home values and more employment growth are what causes migration into an area. So growing jobs, less housing, but the jobs seem to be stronger in this instance, as Philip hypothesized before. Questions, thoughts, ideas? Care to play around with this further? What's up? That is, I'll go back to that here. Yes, so when we're in the scatter plot here, our question is, what does the blue line actually represent? That's the regression line for a simple linear regression. So that is the line that minimizes the total distance from each dot to the line. So it's the trend line, basically. If you have a trend line feature in Excel, I think was what it's called. It minimizes the squared vertical distance between the line. Yeah. So so that's always a great thing to just toss onto your plot because that just indicates the general trend of the data. Mm-hmm. Yes. Let's take a look at the DOF data again that we're using. Let's just do a little summary of DOF here and see what we've got. What we're using here, what we're trying to explain is domestic migration in 2017. So this is a net value of domestic migration, basically who's coming to or leaving an area. And actually maybe a view would be a little bit better of a way to look at it because I can sort from the view mode. So if I look here at domestic migration in 2017 and I sort it, I can see here that it's really a lot of the LA County has the most people leaving by far, 58,000 people left. 17,000 people for Santa Clara, 14,000 for, what is that, Orange, I believe. And if I look down, I can see Riverside's the most positive, but there are a lot of really low values kind of in the middle. And these tend to be the tiny little counties that have very little population. So I want to be able to understand the role of housing cost and employment growth net of the population size. So there's a few ways to do that. One is to do a percentage, but another thing you can do is simply use a control variable. You can just put the population size in there as kind of a control, and then you're not really interpreting it. It's just netting out the effect of population size so that you can look at the other two variables. It's more of like a modeling question than a programming one necessarily, so I don't want to like harp on it too deeply, but that's a very, very substantive and worthwhile point to bring up. Any other questions, thoughts? Cool. All right, so now that we've got this, again, I would really highly recommend using kind of this little best fit line mechanism to display your information if you've got two things and you want to just look at the relationship of them. All right, let's move on to section 3 then, some additional functionality with packages. I think I'd mentioned that there are a lot of things you can do beyond just the base version of R. Making a package is fairly easy. A lot of intrepid researchers, people working on a topic will develop something. They'll develop a new estimator, they'll develop a new index, they'll develop a new technique that processes specific data in a specific sort of way and save it as a package. You can go to ourproject.org, and I believe they have a list of all the packages that they have. It might not be right here, I apologize. Well, in any case, there's tons of them, Paul. I can install a package if I know what it is, just by a single line here, or, Hao-Yan, where was that again? I use the base distribution a lot. Hao-Yan's better with our studio for adding, or for, where would I pull like the list of all the packages?
Oh.
Yeah.
Oh yeah. You can click this install.
Mm-hmm.
And search for the name and click install, and it will automatically do
Okay,
that.
cool. And I think this is the list of all the things I have installed on my computer or that I've used over the years. Create compact hash digests, various R programming tools for data manipulation, additional graphics packages, tools for handling spatial data objects. It's kind of endless. And then actually what I should have led with is each of these packages has a pretty standard type of reference material available. So this SF is a basic mapping package. And it should have all of its regular information and then a PDF reference manual, which describes all of what it does here and each of its functions. So what we're going to do now is make sure that we have all these packages installed. There's 4 of them that I want to go over. A mapping one, do by, which allows some more useful data summarization, scatterplot 3D, which is kind of fun, and then foreign, which is a package that allows you to read and write DBF files, which does anybody here use GIS and spatial data, spatial information? Oh, good, okay. This was like a game changer for me. So hopefully it'll be somewhat helpful. So the first step is to install all the packages. Like Hao-Yan mentioned, you can install them here, or you can just do a line of code and install them right from the command prompt. So I'm just going to install them all here, and they're all installed on my machine already. So this could take a few seconds probably. Yes, it'll download it, it'll put it in the proper directory for you so that you can access it. Mm-hmm. There are? I'm not sure. You have your mic button? You can describe more. Yeah. It's the person talking picture.
I'm sorry, I don't like to talk. All right, am I talking too loud?
No.
Well, one of the things we deal with at our department, security settings don't let us use pip or things like that to install Python.
Mm-hmm.
So we have to install wheel files. Does R have the equivalent?
I don't know. I would have to probably refer to Lauren here still? Lauren Steely, who's teaching some of the subsequent R demos in the analyst track, might have a better handle on that. R is really good with a lot of workarounds, but it did take me a while to install it on this is my personal computer. It's got all my stuff on it versus my work one, which is over there. So you might encounter some issues like that.
Sorry, I come from the Python world. In Python, you can download what is called a wheel file with the last 3 digits being WHL. And then you use your pip installation utility to install from there.
Cool. Any other questions? Thoughts? Cool, thank you. All right, so once the package has been installed, it's probably in the right spot, unless you've run up against any firewalls or issues like that. Each time you use a package, you'll need to declare it in your instance or your session of R. So you'll have to run a separate code, a command called library, and just the name of the package with no quotes. This is great stuff to put in the preamble right up front. So if you're using something over and over again, I would start your code with a couple of things. Options scipen equals 999, options strings as factors equals false, and then whichever commonly used packages. Just put that at the very start, run those 6 lines for each session of R, and you're good to go. So I'm going to activate all these 4 packages right now. It'll usually check. And is everyone good? Raise your hand if you've got any questions. All right, cool.
Yeah, I'm still waiting for it to download.
Okay.
Yeah.
We'll give it another second here. Yes? Sorry.
How do you usually find out which package you need? Just Google?
That's a good question.
Is there any website that shows like the list of like basic package you can download and try?
You know, in most instances, in my experience, I've gradually come across what I've needed. What I'm going to show you is a method of just collapsing data that's similar to a pivot table in Excel, and that requires the do by package, which is one of our 4 here. Statmethods.net is pretty good about you know, if you're doing some more data and statistical manipulations, it will indicate if there's a package. One that's great is ggplot2. I'm not going to get into it here, but I know I've heard during the break that a lot of people like to make really nice graphics with ggplot2. So that's got a library and examples. I don't have a great sense. Does anyone have an idea of where a comprehensive package listing is? I'll give that some thought and get back to you guys if I do have that. But you know, oftentimes you do just come across it in your work that you'll need something, or you can just Google around. Like this SF package, I don't use frequently, but you'll see in a second it does some cool visualizations without needing any kind of GIS. So anyone still waiting for packages to download? 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. I'll start and go slowly if that's all right, just to keep us on track. This scatterplot 3D one is kind of fun, just because, and I bring it up just because we've done 2-dimensional scatter plots. It's a little tricky to visualize. Whoa, right? So instead of a 2-dimensional, you have a 3-dimensional space here. And this is the relationship at the county level between the log of population, the log of employment, and housing value. I've added a color red, and PCH is the dot type. So this is a very Googleable thing too. This is an argument that you can just put in which kind of dots you want. And this will take other parameters too. You know, one of the disadvantages of SciPen is this issue, but that'll give you a 3-dimensional scatter plot of everything. The next thing that I want to get into is doing some manipulations to an Esri shape file. If we're working with that using the match command that we went over earlier. Has anybody? So you mentioned a bunch of folks are GIS users here. Has anybody come across the issue that it's fairly tricky to replicably join other data into GIS shapefiles. Yeah, it's not great. The join field command is very slow in my experience, and there's a lot of issues again with leading zeros that almost caused me to leave California. This is a really good way to do it, but it's a little bit, you have to be careful. I want to give you a fair warning because shapefiles can be messed up. If you accidentally delete one of the rows from a shapefile when you're working with it in R, it's not going to open again. So I would suggest making a backup, at least the first couple of times you try this in your actual work. If you notice here, and if you're downloading the packages, I'm sorry, hopefully I'm buying a little bit of time by going over the conceptual details first. I've included the 8 constituent parts of a shapefile here. You don't necessarily need all of them, but that's kind of the default output, so I felt I'd just leave it at that as that. The actual spatial typology is stored in this SHP, but the DBF component of a shapefile is the actual attribute table, the actual data in it. So what we can do in R is just make manipulations to this DBF element of a shapefile and work with it that way. Esri also has some functionality for linking R to GIS, although as a lover of open source things, I felt a little bit dirty typing in my Esri credentials into the R console, so I tried to look for a workaround. In any case, what you can do here is this read DBF command, and unfortunately read DBF is not an R-based command, it's part of the foreign package. So you can read your DBF straight from the file path that you have already here, and it's called, I'm going to call it shape. You can do head shape, and you'll see that this is really just, this is just my shapefile of counties in California. And row 58, I'm sorry, and row shape should be 58. And it doesn't have any data in it, it just has a couple of different ID numbers, the area of land, water, the county FP, county FIPS code, and the name itself. One of the things that's a little bit tricky when matching, as I said, is this leading zero issue. And a fairly good workaround for that is to just do these 2 wrapped commands to any of your identifier files. This will just take them and make them into a straight up numeric value. Sometimes you read things in as strings, sometimes they have the 0 issue, sometimes there are other issues. What I like to do is to make a new field in this, and I'm going to call it GeoID2. And what I'm going to do is I'm going to take shape GeoID, I'm going to switch it to a character and then back to a numeric. Boom, problems solved. So run line 231, take a look at your shape again, and then you'll see that this GeoID2 no longer has the leading 0 problem that California is notorious for, in addition to a few other things. So I'm going to do the same thing as before, and I'm going to match a couple of variables from my DOF data to this shapefile. And then I'll be able to actually manipulate them within ArcGIS or whatever else you use. So again, same thing here. We're going to take the POP17 field from the DOF data, match it to shape, and then use the declare the unique identifiers here in the match command. So the unique identifier for shape is GeoID2, the one I just made, and the unique identifier for DOF is ID. Again, running this as numeric as character for all of the inputs will generally help to get rid of any issues you've got there. So I'm going to add POP17, I'm going to add Hoval 16, and I'm going to do a summary of shape. So now in my shape file, I've got these 2 new variables I like to have here. Now this is the part you have to be very careful with. I would suggest double checking to see how many rows you have in this before you hit write DBF. Because what you're doing here is writing the DBF element, and if you have the different number of rows, if you've gotten rid of some or added some, you're going to probably be out of luck. And if I go into ArcMap, should be able to easily see and visualize those columns there in the more advanced GIS. I hear typing, which means I don't have to like fill the empty void space. So. So I can take a look at it here. And then see that I have these new 2 columns. And if I want to make the nice chloropleth map here by population, or maybe by home values, let's make red the high one because it's more alarmist. There we go. I can also do a little bit of this right in R itself. So I should leave that up for more than a quarter second. I can also do some of this right in R itself using this SF package. So the SF package comes with this read SF function, which reads in the shapefile itself. So the way you do this is you need this argument here, DSN, just to indicate that you're using the current working directory. That's just how this particular command read SF works. And then you want to declare what layer file you're working with. The layer file is going to be this here, and enter that without an extension. And we're going to read this in and save it as counties. So that's line 247 here on mine. And we can look at counties in the same way. And this is going to give you a little bit different of a head function because this isn't a regular data frame like we've been working with before. This is a different file structure here. This actually has the layer. It's giving us some of the headers. It's saying that there are 8 more variables, including the ones that we just saved a moment ago, and that it's a polygon with certain characteristics. Plot is, this one's pretty crazy. If you run line 251, you can actually just plot it in R. So you can just do a really basic chloropleth map here, even if you're a non-ArcGIS user. If you want to learn more about plot from SF, it's a PDF manual, very Googleable, and it'll give you all the should give you all the parameters here. All the other things that you can put in or not. I've put in a few for you by making a slightly better plot here. I'm going to do the next plot I'm going to do here is in line 254. The layer is counties, brackets and quotes will encapsulate the field that you want to actually put on the map. For breaks, the breakpoints, it's always important in spatial representation to be somewhat authentic with your breakpoints. This isn't terribly useful here because I don't have too much of a gradation. But Jenks optimization is a pretty good way to do it. It kind of picks the natural breakpoints for you. One of the other main things is the color palette, PAL. I'm going to use an SF colors function, and I'm going to do 10 different colors. So let's take a look at what line 254 looks like if you're not there already. I've also added axes here if you are interested in having the lat long. So this is just a quick way, if you actually have spatial data and want to generate a quick little plot, to do this. Again, you can just use the Jenks optimization that I've got here in the default. You can do this color palette, or you can look up the color palettes available. This should be another way to do it. Plot SF object. All right, so we've got another half hour, and we've got just a handful more plots left to go. So we're making great time with this. I appreciate everyone's patience with the various levels of system integration and whatnot, and that'll leave some more time for kind of questions and going around at the end. So we've got this cool spatial plot that we can do. Again, it's not a package I use super frequently, but it can be something you want to, if you just want to plop up a nice little map using just R. Let's get into section 4 here, just some more plots that are useful. Again, ggplot2 is something that, oh yeah, she's doing like this little heart thing. Yeah. ggplot2 is a great package for that. I'm just sticking with some of the base distribution plots here. We can go over it in a little bit more detail if we've got some time at the end. Here's just a fun plot. I'm going to declare X as a sequence from 1 to 400. Just numbers. going to do some math to make y. And you can always plot x, y. Woo, fun. All right. Sorry, that's not very useful. Another somewhat useful tool, if you don't actually have, if you just have a few data points that you want to plot, rather than making a whole file in Excel or whatever, uploading CSVs, what have you, you can just make a data frame manually here. And that's what this is an example of. This is from work I did in Phoenix a long time ago about the number of residential, commercial, vacant, and nuisance parcels in historic downtown Phoenix. So what I'm basically doing is I'm creating five vectors here. I'm going to call them year for the year. It's a historical study. Residential, commercial, vacant, and nuisance. So what this is these are just numbers separated by commas. And this is technically a function called combine, which combines them. So if I run all of these, I can turn them into a data frame here. Again, a data frame command, plopping them all together like this, because these are all 5 objects right now. I'm going to save the data frame as PHX because this is a study in Phoenix. And you can see here that I've made a little data frame. So this is a useful way if you actually just have values you want to type in. And again, we've been doing some of the very basic plots to start off with. Here's a real basic plot. R will create default dimensions, default everything. And ooh, that's not very good, is it? Basically, I've plotted on the x-axis the year, and on the y-axis the number of residential parcels. So let's just add some things here. Let's change the type to O. The type is the is this. It's a dot right now. You'll see in a second what O changes it to. Let's declare some X limits. Again, this is this little combine command. The X limits, I know that my years go from 1915 to 1963, so I can just specify them as 1910 to 1970. Y limits, well, looking at my data, I eventually want to make a plot of all 4 of these types of land use. Looks like the lowest is 200 some and the highest is 1300. So I'll do my Y limits from 100 to 400. And I'll pick a color. Does anyone have a different color they'd prefer? From that fun color list of, toasted almond or whatever? No? All right. So let's do a plot. This type O, what it does is I guess it makes the, it's got an open ending and then it has the line itself. Once you have a plot, lines is another command that'll add a line to the same existing plot that's open in your window. So what I'm going to do is I'm going to run lines for each of commercial, vacant, and nuisance here, giving them a different color, the same type, so that they're all lines. And then you can add a couple of little parameters if you want to tinker with LWD, which is the line width, LTY, which is the line type. Again, if you just want to search, this might be your easiest way. Line types in R, this is like solid, dash, dotted, etc. So if I run all these here, I can start to see this is my number of residential parcels in downtown Phoenix went down during this key period of suburbanization. Number of commercial parcels, I apologize, I'm actually quite colorblind, which makes GIS terrible. Commercial parcels went up. The number of vacant parcels went down and then up again after World War II. And the number of nuisance parcels or industrial parcels, which is forest green, which I'm assuming is this line here. Is that correct? Okay, thank you, everybody. Went up and then is a little bit standard here. So the line widths are aren't a little bit great, so I can add a LWD equals 2 here on my first line if I want to tinker with that. Okay, that looks perhaps a little bit better. And then yellow is not very visible, so I think there's probably a dark yellow. There doesn't seem to be a dark yellow. How about chartreuse? Okay, and again, chartreuse could use a little bit wider. I'm going to add LWD equals 2 to the end of that one. and run it again. So yours should look roughly like this. If you want to tinker with it, feel free. Just make sure you add these arguments, not too many spaces, a comma between each one. And if you want to learn more about graphics arguments, there are a lot of graphics commands, plots and hists and lines. The help for that is actually under par. So par stands for graphical parameters in this sense. So this is where you can kind of get the information on box type. CEX is helpful if you want to scale things a little bit, especially for legends. If you do CEX equals 0.8, it'll just scale everything down so it fits a bit. So we've got kind of the makings of a plot here. And let's just gradually add a little bit more, starting in line 285. So what I've done here in line, so the code for this plot, and ggplot2 is probably way better, to be perfectly honest, right? Okay. A ggplot2 will eventually get you a better plot, but this you'll get an understanding of kind of what things you can toggle and you can move around with. I've got my x limits, my y limits. I've added an argument for axes equals false. That'll allow me to specify my axes separately. So those first 4 lines here, 285 through 288, have just basically given me 4 different things here. Axis 1 is the x-axis. So if I actually want the axes to be customized, I really just have 3 points of data for 3 years. I want the tick marks to be at these years, and I also want the label to be at those years.
That's what I want too. Hey, really quick,
Sorry.
guys. Here. So it's noon right now. At 12:30, we're going to be serving lunch. Lunch is going to be in the kitchen. It's going to be like a box lunch. We have about a half hour to get everybody something to eat. But when you've got that, if you could come, you want to come back in here and have your meal. At 1 o'clock, we're going to have some more keynotes, sort of a lunch and talk kind of thing. So just want to kind of give an idea of what it's going to like. And we're going to try to get as many people through the kitchen as we can. So we'll do our best. But anyways, as you were, unpause.
We'll be done in 10.
Really? Oh, cool.
Yeah,
All right.
roughly.
Well, cool.
Yep.
Come on out and chill.
Thanks, John. All right. Again, axis 1. I can specify axis 2. It's the y-axis. I'm not as concerned about it. I can put a box around it. Again, I can add these horizontal lines, these little guidelines, A, B line. Here, I can actually specify where I want them. One of my favorite little tricks, doing some little gray guidelines like this. I can give a main title. I can put a legend up here on the top right, give it a little inset, specify what I want the legend to say. I'm just going to say R, C, V, and N for the 4 types of land use. And give it a range of end types, line types, and scale it down a little bit, CEX. So this is going to be 0.7 times the full size. So there's a little bit of a legend that works for now. Little title on the X, a little title on the Y, which you can't see because of how it is here. And I've got a 90% ready to go graph. You can do to export it. Again, I had shown you earlier a PDF export version, but if you're working in RStudio, it's pretty easy to just save it as an image here. And you can actually tinker with the size up here if you want it a little bit wider or a little bit higher. Should be able to update the preview there. But in any case, you're able to just save this to, it has your working directory here. I'll just save it as rplot. And then if we go to our gradually growing list of things in our directory, we can see a plot. All right, sound good? ggplot2 next for the 2020 School of Data. All right, last couple of tasks here that I think are really useful data manipulation things before we get to lunch. Really handy trick is to be able to go between different spatial scales or different scales of data. spatial or non-spatial. What we work with here is a lot of census tract data nested within cities, nested within counties, nested within states. So the ability to go back and forth really easily is very useful. So this is where that do by package is going to come in handy. So if you had some trouble installing do by, I apologize, but this is where that comes in handy. So let's go back to this DOF data set here that we've created before with all of our information. And you'll notice I put a column here for MPO before. So this is county level data, but what if I want to summarize it at the regional level or the MPO level? One thing I can do to see how many MPOs there are is to run these couple of nested codes here to just tell me how many unique values there are in MPO, in DOF $MPO. So I'm going to do a length unique unlist MPO, a DOF MPO. And there are 5. Another way I can do this is table DOF $MPO. And this is going to give me a table of how many observations there are in each category here. That one's not in the code file, so that's one maybe if you want to put in there, table. So what I'm going to do here is I'm going to summarize the population information, take the sum and then subsequently the mean by MPO using this summary by command. So the way the syntax works for this is you start with the columns that you want to take the sum of at a different level, at a higher level. And then you're going to do a tilde, and then you're going to declare what you want to summarize them to, say the MPO level in this case. You can, for convenience, it allows you to declare the data set that you're using, so you don't have to do the dollar signs every time. And then capital fun, hey, it allows you to declare the function. So I want a sum here. I'm going to save all of this in a new data frame called DOF sum. So if I run line 305 here, and then I can just type it. I know this is going to be pretty small. So DOF sum, I can just take a quick look at. And this is going to give me the population and employment for each of the major 4 regions in California, and then all the rest. I apologize to the all the rest category for being all the rest, but this is just a data demonstration. One of the things I think people forget a lot is just how much the sheer size of Southern California versus the Bay Area. We're nearly triple, 19 million versus 7.7 million in population. Right? Yeah. Yeah, we have nearly 3 times the population. We're 49.1% of the state here. So if you think of where political power is and such. I will keep my mouth shut from here on out because I work here. A mean is helpful too, but I want to give you a little bit of caution. What do you think the problem might be by using this lines 307 and 308 here? DOF mean. So I'm looking at the mean. I'm doing the summary by command to get a mean value across regions here. For SCAG region, it's actually 398. Why is this problematic? What's my original data? What level is it at? County. I originally had county data. So I had county level data, Alameda County, for example, and their home value is 649,000. There are 9 counties in the ABAG region, 6 in the SCAG region, Sacramento, 1 in the San Diego area, San Diego County, and 6 here. If I'm taking the mean, I'm taking the mean of counties. So this 398,000 is the mean across the 6 counties of Southern California. This mean of 685,000 is the mean of the 9 counties in the Bay Area. So it's just kind of a reminder of how you actually want to represent your data. Can you actually aggregate it to that scale? One thing that might be better is to do it by a smaller area, weight by population, something like that. So just kind of a bit of a caution here when you're doing things with different spatial or temporal scales for representation purposes. So I can do a little bar plot here, line 311. And the bar plot is actually of the sum. So this is the population sum, again, this is us, that's everybody else in terms of size. And I can add a names argument to the bar plot as well. And the names argument is going to be straight from DOF sum as well, which I just made up here. So bar plot's another easy, straightforward command, which you can add a lot of graphical parameters to, but it's useful. And I'm going to do just that here. Get rid of my axes, change the colors, specify the range, do these little ab lines, which are kind of the guidelines, and then put a nice little box around it. And this is 2017 population by metropolitan planning organization in millions, to get a sense of relative sizes in the region. So that's the end of the tutorial. I'm actually kind of surprised we went through it pretty quickly. And was this useful? Did you get through it all right? I've got a few minutes to come around, but yeah, otherwise, thank you a lot for your attention.